All right. Good morning here from the West Coast. And thanks all to joining us here for our webinar on how to budget for your VR project. Looking forward to this topic today. We're just going to take a couple of minutes while folks are still coming in. So we'll, just hang out for a second. But really excited about this topic today. If this is your first webinar with us, welcome. Really excited to have you all. We have a whole series of webinars that we've been doing throughout this social distancing time. A lot of the webinars that we've done in the past have focused on use cases, how folks are utilizing VR, when you might use VR in, specific industries or, for training, for remote collaboration. So we're not really going to dive into those topics as much today. Today is really going to be all about budgeting. So hopefully the folks who are coming in today have a good idea of what they want to do with VR. If you're curious about learning more about these other topics, things like deep dives on projection VR or deep dives into any of these kinds of hardware devices that you see here, we've covered these in pretty good detail. So be looking out for our other webinars. Just going to give it another minute or two here as we wait for another couple folks to join. But let's jump in. So I'll just make an introduction here. So we've got myself. My name's Dan Tinkham. I've been with worldviz for almost 6 years now. I'm the head of sales for the Americas. And then we've also got Matthias Pusch, our CEO, on the line.
Hi, everybody. So I'm one of the old timers, even though I'm not going back to the early 90s of VR like one of our other co-founders. I basically stumbled into VR at the end of the 90s as an engineer in like 98. And I've been with worldviz since inception. worldviz was started in 2002. And I've obviously seen over time many VR projects for academics and also for industrial clients, and learned a lot obviously about how to use VR and what works and what doesn't work so well. And we're as a company always trying to share with our clients and our partners that kind of context that we have learned about how this new technology can really help create a value. And so my background is I'm an engineer. I'm a German guy, a German engineer, and I've been working here at worldviz for the last almost 20 years now. So it's been a long time. So Dan, thanks.
Yeah, of course, and thanks, Matthias. So we've still got a couple people trickling in, but we're just going to get the show on the road. Hopefully we'll be all wrapped up in a little under an hour. I'm just going to give a little bit of background on worldviz for those of you who are new to our webinars. So as Matthias mentioned, we were founded in 2002. So we have been in this VR world since way before there was any kind of consumer headsets. We really were helping put together some of the very first commercially supported and integrated VR systems on the market. Utilizing, military style headsets, things like that. So originally we were actually coming out of an academic background. worldviz came out of a psychology lab at UC Santa Barbara. And over the years, as the sort of different real valuable business use cases for VR, in the aerospace world and the training world have come together, we've really kind of brought in more industrial customers over that time too. But at the same time, our kind of original core systems, our core software was focused towards the research market. So academic customers have been a really kind of core part of our business for, the entirety of worldviz. So that's just a little bit of background on who we are. Give you guys a little context for what we do. I'm going to jump in now on the topics. So today's a pretty cool webinar day. We're going to basically just be talking all about budgets. So Matthias and I both work on the sales side, so it's a space that we can speak to pretty confidently. The first thing we're going to do is really just break down what goes into a VR budget. So hopefully, you guys will learn a little bit about all the different components that you might want to consider when you're setting up a serious VR project. This is really going to be in both the academic context and the more commercial industrial context. But we'll be speaking a little bit to both. So Matthias and I are going to cover this first part. Matthias is going to go on a deep dive with hardware, and then I'll be talking a little bit about software and facilities, things like that. After that, we're just going to do a kind of a brief overview of application development considerations. So what you need to know, what you need to really think about when you're developing your own content. It's not going to be a super deep dive, but is going to hopefully give you an idea and some resources that you can start looking into in terms of what you need to do to really confidently, enter into this sort of ideation phase that you're ideally in now for your VR project. And then after that, just to wrap things up, we're going to look at a couple of typical VR budgets for some specific types of hardware setups, a couple specific applications. So the one cool thing that we do at worldviz with our webinars is we actually have a QA section. So you'll notice that we have this question and answer little panel here as an attendee. Submit your questions to us throughout the webinar. We won't be answering them in real time, but at the very end, what we do is we actually will take as many questions as we can, and we'll answer them in a live QA section at the end. So stick around for that. It's going to be a good time to get some feedback from you all, and hopefully we'll be able to speak to your questions. I'm going to hand it back over to Matthias now, and he's gonna take it from here.
Yeah. So thanks everybody. I'm going to talk first about VR hardware, and when you talk about hardware, it's clear that you're talking about pretty much like right now. A lot of people just understand when they hear VR the head-mounted display or VR headset, which these days obviously the very famous makers of that is Oculus and HTC Vive, and on the gaming side the Valve Index. And then on the business side, Microsoft, like mixed reality, has made a name for itself. But a lot of people, when they think about hardware, immediately think about just head-mounted displays. So we'll talk about that. We'll also talk about projection, and projection is a slightly different animal. It's effectively when you have a projection system, you're using projectors, 3D projectors, in order to create a space around you that's it's to a certain extent interactive. And a lot of people wouldn't believe it, but like a large projection system gives a very similar immersive experience to like a head-mounted display, but it allows multiple people to experience that together, which is an interesting use case. We see it a lot for showrooms, effectively, where people want to show a group of people geometrical layout of something. So we'll talk about that on the display side. On the rendering side, what you always need is some kind of a computer that renders the images that you see. So we'll talk about that. You need a graphics card, like for like a phone, the graphics card's integrated into the phone device. But a computer, a higher-end computer, has a separate graphics card that's either like already in it when you buy it, or you can add it. Some of these graphics cards can be expensive when they are specialized. We talk about tracking, which is typically a component that's needed for interactive virtual reality, because you want to be able to move your hands around, so something needs to track your hands, and you want to be able to look around, so something needs to track your head. So we have to talk about that. For consumer systems, that's often included. For professional systems, that's oftentimes a separate component. And we talk about sensors, which is effectively just adding all kinds of devices to your VR system that measures things like biofeedback or eye movements or certain body movements, gait, posture, stuff like that. So let's dive in and look at the displays and look at the consumer displays right now that we find are the most prominent ones that are kind of mass produced right now. And the one on the Oculus side is really the Oculus Rift S right now, which is the one that's a very high-end PC-based headset. It's a beautiful headset. We have used it a whole bunch of times. It's working really well for a headset with inside-out tracking. There's the Oculus Quest, which I think is right now really considered the best-selling headset. Probably it really sells. It's got a low price point, and the cool thing about the Oculus Quest is that it's integrated. It's basically self-contained. It uses almost like a phone technology to provide the rendering for like kind of the small scale rendering, but it also can connect with the cable to a PC, and it also can work very similar to the Oculus Rift as a PC-based head-mounted display. So it's got both sides, and people find that interesting, and people are buying that a lot right now. Then there's the Vive Pro Eye, which is really on the professional side, probably the leading headset right now. HTC has really created this and realized that there is a market on the professional in the professional arena where people need eye tracking and where people want more precise tracking. And so, yeah, that's targeting that market right now. It's obviously also not a consumer price point. It's a little higher. Then HTC also has an HMD that's more targeting the consumer side, and that's the Vive Cosmos right now, which again is an interesting HMD because it's got inside-out technology again. And then on the gaming side, there's the Valve Index, which really is from a gaming company for gamers. It's really targeting the game use case, but it's a beautiful HMD. It very much compares with the Vive Pro, also technology-wise. And then there's the HP Reverb and the other Windows mixed reality headsets. There's the Samsung Odyssey and a bunch of others, which are all pretty cool headsets as well. And obviously HP is really targeting more the professional application market. And pretty much most of the HMDs shown you have inside out tracking. They look with cameras for your hands, with the exception of the Vive Pro Eye. And actually, yeah, and the exception of the Valve Index as well. So let's jump to the next slide here, which is the higher end headsets. They almost can't call it consumer anymore when it costs like $5,000 or more. So these like higher end headsets, a lot of them haven't been really 100% released yet, or they're just in the release kind of stadium right now. But they provide in many cases higher resolution than the consumer headsets and a higher feature set in certain ways, sometimes tracking and having proprietary eye tracking and stuff like that. But anyways, the price point for those is obviously higher. And in many cases, you also need a pretty beefy PC to actually run them. So yeah, on the rendering side, the cost for these will also be pretty substantial. But that's really on the display headset side. You're looking at somewhere on the consumer side, as said here, from like, let's say, 400 to like 1,000, 1,500 bucks, or on the higher end consumer side, like slightly professional, like I would say, 1,000 to 10,000 bucks, depending on what you're looking at. And now on the projection side, really the cost of a projection system depends a lot on the cost of the projectors that you're using. So there's projectors out there that can do the requirements, can fill the requirements of a stereo projection system that start around $5,000 on the professional side. And I've put a price tag of $30,000 here for the higher end projectors, but reality is the sky is the limit. There's like some high end projectors out there that cost over $200,000 per projector. Now, when you have a system that consists out of multiple projectors, like shown on that image at the right bottom, this is a 6 projector system. Then obviously you have to, the cost for that is 6 projectors plus like the effort of mounting and blending and all that. So on the projection hardware side for a system like this, just projection hardware and mounting, you're looking at $50,000 to $75,000 typically. But if you need a pretty beefy rendering computer for that as well. And these kind of large projection systems are used as displays for groups of people. Like we have customers who have it like in universities, and they immerse a whole class of students into an immersive environment, right? So you can fit in those systems easily, like 10, 20 people if it's a system like shown at the right lower end here. Yeah, that's the projection display side. Rendering computer, what do you expect there, like money-wise? On the rendering side, if you render for a head-mounted display for a headset, you don't really need anything else but a high-end gaming computer. And when you look at high-end gaming computers, they range for like I would say starting at like $1,000 to like let's say $5,000, right? Depending on like how you want to configure that computer. When you need a computer for a projection system, then you're talking a slightly different animal, because for a projection system, you need so-called cards that can do quad buffering, which are the NVIDIA Quadro cards, where like one of the higher end Quadro cards, like a 6,000 one, would cost, just as an example, would cost for $4,300. And so if you run, let's say, a system with 3 projectors and you want to run it off 3 graphics cards, then you would need, just for the graphics cards, you would need to spend like 12,000 or 13,000 bucks or something. And then you need a computer that fits 3 graphics cards, which is a completely different computer. It's not like a gaming computer anymore, which then easily also costs you like 5,000 or 6,000 bucks. And so it's becoming a more expensive system. But these like showroom systems obviously are not a commodity. They're really used for specific purposes. So let's go on the tracking side for the hardware. What do we need there? Again, on the consumer side, the tracking is included in the HMDs. So when you buy a Oculus Rift S, it has inside-out tracking. When you buy a Vive Cosmo, it's got inside-out tracking. When you buy a Vive Pro I, it's got these lighthouse systems that you have to set up. But these HMDs, the consumer-facing headsets, are really oftentimes containing a functional tracking solution. It might not be very precise. It might not give you the ability to have multiple people in the same space and see each other, but it is very powerful. And obviously, there's no extra cost for it, which is great. On the research side for head-mounted displays, we sometimes see researchers who have to augment the consumer systems with the higher-end tracking systems because they have special requirements. They need high precision, or they need a really large space, or they need multiple people that need to be accurately represented in the space. And so, yeah, for these kind of use cases, you might have to add a high-end tracking system to a consumer head-mounted display systems. Yeah, that's really the HMD side. On the projection side, you need some kind of a professional tracking solution, because you need to track the main person that wants to walk around and interact in the system. You need to track their head position and also their hands to a certain extent. And so yeah, for a system like that, you usually pay for like a system that's on one wall. You put like 18,000 here, you pay 18, 20,000 something. And if it's a system that's around a corner or a whole room, then it's more expensive. But just to throw out a number, it's typically between like whatever 18,000 and like 30,000 bucks is very typical for a projection system tracking. If it's a smaller one, if it's a huge room, then it can be significantly more expensive. Oops, 1 second here. So now the last point I want to talk about is the hardware, the sensor technologies. So on the sensor technology, which basically means you can now measure like other things than they already measured for virtual reality. For virtual reality, you measure the head position and orientation and the hand position and orientation. But if you want to measure, let's say, like the hand movements, like here shown on that picture, you can use data gloves. If you want to measure biofeedback, which we see a lot on the research side, you can use a system like from BioPack, which like price tags for that are typically with BioPack, I think 8,000 or 20,000 bucks if you want to measure heart rate and skin conductance and breathing frequency, and maybe they have add-ons for measuring even EEG and brain activity in real time, which is pretty cool. You can add that. We call those sensor devices. There's obviously a lot of haptic devices that provide force feedback, which can be pretty expensive and also pretty hard to integrate. And then there's whole like mocap devices. If the goal of your simulation is to not only interact in virtual reality, but also capture motion, really accurate body movements, and maybe use them later for creating a simulation or recording a simulation. Then there's mocap systems you can add, and there's many other sensors. In theory, even like if you would add like a consumer device, like an Apple Watch, it could also be considered a sensor device. But these sensor devices vary like widely in terms of cost, and really it depends on the use case that you have for your system, which sensor devices you would add. should probably contact us for a quote if you want a specific price on one of these sensors. So at that point, I think I'll hand this presentation back over to Dan. Let's see if I can.
Yeah,
do that
let me jump in here. I got this. Yeah. So I'll go ahead and present on my side, and let me just turn my webcam back on. Thanks, Matthias, for the hardware rundown. So I'm going to speak a little bit about the software now. So obviously there's a couple different components. And one thing before I jump in here, I said this at the top, but we've got a little bit more attendees now. We're not really diving too much into use cases right now. We've done a ton of webinars on specific use cases. So we've got a whole channel on our YouTube page where you can see all of our old webinars covering topics like training, remote collaboration, and all of these hardware components in detail. So if you want to learn more about what any of these sensors or things are doing, we've definitely covered that in past iterations of our webinars here. So to speak a little bit to the software side, obviously you need to have, you've got your hardware, and then the hardware is in service of the software, which is going to be generating your virtual environment. So there's a few options out there, and probably the most common ones, the most utilized ones out there are really game engines. So in the same way that the hardware on the VR side is really tied into the gaming market, the software is as well. And the two kind of big players in this space are Unity and Unreal. In terms of cost, Unity used to be really low cost, but they've actually upped the pricing for their seats in recent years. So for educational institutions, for professional institutions, you're looking at about $1,800 to $2,400 per seat. Unity is, very widely used in mobile game development. So its kind of first big hit was Pokemon Go. So it gives you an idea. It's a really powerful tool with broad capabilities, but isn't necessarily VR specific, but is used a lot in the VR space. Unreal, very similarly, they actually have an even more kind of accessible costing scheme where it's revenue based. So until you're making over $1 million in revenue on the applications that you've developed with Unreal, it's actually free to use. So Unreal, they're the makers of Fortnite from Epic Publishing. So it's definitely a large business, but again, very focused on gaming and these kind of mass market applications. For more specialty tools, there's definitely a number of tools out there. I'll speak to a second about our software, which is Vizard. It's what we would call a scientific engine. It's doing a lot of the same things as a game engine in terms of, having a real-time graphics engine, things like that. But in the case of Vizard, it's very much set up for scientific research, for professional applications, and it's really made specifically for virtual reality. And specifically virtual reality in a kind of Windows PC-based context. So it's Python-based, very quick to generate virtual environments. We provide kind of framing that allows you to, just plug into a Vive or something like that very quickly. The pricing for Vizard is different from Unity and Unreal. We actually offer a perpetual license. So when you buy Vizard, you have it for life. It's yours forever. And perpetual license of Vizard, the development edition, which is kind of your entry level, it's about $4,000 to $6,000 depending on whether you're a commercial entity or an academic entity. And the prices that we're giving here are really more towards the North American market, just as a heads up. But that's just a kind of a good benchmark. Then on the commercial side, we also have an enterprise license. So if you wanted to commercially distribute Vizard executables, or if you wanted to do other types of more advanced applications like streaming real-time motion capture data, you might need an enterprise license. And those range from about $6,000 to $10,000, depending, again, on if you're academic or commercial. So we also offer multi-seat licenses at a discounted price. So if you're trying to build out a lab, you can get a 5 or a 10-seat license. And then the cost per license comes down to about $2,000 per seat. So that's just on the software side, kind of an idea of what you might need for budgeting. You might also be needing some of these 3D modeling tools, especially if you're going to be building your own content in-house. We're big Autodesk users at worldviz, so we use 3ds Max, but there's a ton of different software out there. Obviously, Autodesk is a a little bit more of a subscription-based model. But then there's more like Blender is free to use, I think, and Sketchfab is also lower cost as well with student licenses and things like that. So, if you have specific questions about, what an art pipeline might look like, we can definitely speak to that in more detail on a one-on-one conversation. It's really a huge, broad world, so can't dive into all the different specifics at this point, but that's just another one to kind of keep on the radar if you're going to be developing a lot of VR content. This is facilities. So, you've got your VR hardware, you've selected the software. Now you need somewhere to actually house your VR equipment. So you'll probably see a lot of videos online of people, in headsets breaking their glass living room tables, right, because they don't have enough room to move around. So it is good to have a dedicated space for your virtual reality experience center or lab. In our experience, you really can, we've seen customers who have, even just a utility closet shaped space that's dedicated to VR. And, you can have a fairly low footprint environment too. But I would say the very minimum for a headset user would probably be about a 5 by 5 foot space. That would be a desk and like a seated situation, kind of how I am now. And that's just running them through like maybe an experiment where they're using game controllers to navigate or something like that. So that would be the minimum. When you're getting up more into these projection environments, you're talking about a bigger space, right? So what we really do with our projection systems, you can get screens, but oftentimes we're actually just projecting directly on the wall. So you can just paint the wall white. Oftentimes we'll even paint around the projection surface dark to really make that image pop out. And ideally, the one thing, if you're really looking at a projection system, is to try and find a space with kind of higher ceilings. And the reason for that is that the higher you can mount that projector, these ultra short throw projectors that we use, the higher you can mount them. They're sitting just a few feet off the wall, and then they project straight down. So the higher the projector is, the higher the overall image is. And that can, it's subjective. I mean, obviously you can have projectors in any kind of configuration, like on the floor, in different ways like that. But the higher the projector is, generally the higher your image is, which creates a larger field of view for the users. So that's one thing to keep in mind. Obviously, we can't really budget for what your facility renovations look like. I would say when we're involved with a large academic lab or a large showroom, there's a pretty serious construction component, right? I mean, folks are bringing in new power outlets. One kind of fun thing that we've definitely encountered is like fire requirements, sprinklers in the ceiling, or different fire alarms on the walls. So it's really good to have a good idea of what your facilities look like. And I would say for any kind of major installation we do, there's almost always a component of minor renovations, or where we're at least talking with the folks who run the facilities, so that we understand, what the conditions are going to be like when we come in and install a space. So that's just kind of part of the whole package here. One thing to definitely keep in mind. The next part here, I believe, is our personnel section. Yeah. So I'm going to have Matthias speak to this a little bit, but the one thing that, before Matthias jumps back in here, that I'd like to say about personnel is we see a lot of success when you've got a dedicated person who's running your lab, right? So if you've got a person who really owns it and is the go-to person who you can call in when people want to take a tour of the facility, and is also, maybe running your research program, or, just owning the space, it really makes a big difference, as opposed to having, the equipment, but nobody who's really in charge of it, so to speak. So bigger facilities are definitely going to have more folks who are going to be in the kind of management position of the facility. But Matthias here is actually going to talk to the commercial side for a second too, because he's got a little bit of a story to tell.
Yeah, well, when we prepared for this webinar, we were like, well, what is a good example for personnel? And I do have, like, doing this for so many years, I've seen a lot of like labs succeed and fail. So like the first observation on the research labs is that virtual reality in many cases actually creates a problem for the researcher, which is also a good thing. The problem is that there's so many people, when you have a kind of a cool virtual reality lab, there's so many people who want to just see it. And So basically the problem is that you have to do research, but at the same time, there's always visitors coming in who actually want to experience the virtual reality lab. They want to see some virtual reality, as they say. And so in an academic research setting, and typically what ends up happening is that there's a point person, like one of the grad students, one of the postdocs, or sometimes just an employee, a staff member, who is basically the go-to person when someone wants a virtual reality demo. And in many cases, we have seen that then like research labs that get a lot of requirements for such VR demos are going to design, like basically decide that Friday afternoon is their VR demo day, or so they define certain times when people can come in and see virtual reality demos and visitors can come in. And we have seen actually a significant amount of cases where these research labs get so popular that the university starts showing them to prospective parents as just one item on the sightseeing tour of the university. And so we have seen cases where the university decides to just duplicate an existing research system with the purpose of just using it as a showroom, basically. But that's basically back to personnel. That means you probably want one person, even in a research setting, that's the point person for the virtual reality system. And you should probably also like think about like what's the demos that you can show if someone just wants a VR demo. On the industrial side, it's in a way similar. Like the implementations of VR that we have seen being successful are really the ones where there have been certain people basically designated to be in charge of the VR system. One example I always tell is a story about Siemens. Like many years ago, I think 15 years ago, me as a German guy, I was invited to Siemens headquarters, the original Siemens building in Erlangen. I was pretty proud of that. And for a virtual reality presentation. And so the Siemens headquarters looked at that at the time as a selling tool to actually show potential customers like certain features of some of the apparatus of the machines, the medical machines they are developing, and upselling them on the newest and latest, greatest technology, basically. And so the group that originally started owning this kind of project was a visualization group. And my first meeting there, I think it was 7 people or 8 people or something like that. And then they I think designated initially 1 person and then later on 3 people to that project. And it grew as a project internally, and it grew in all kinds of different divisions. And then eventually they had to go to trade shows and show their VR systems at trade shows just as a way of showing customers prospective system configurations. And eventually it also spread even in different continents. So right now Siemens in North America is using it for different use cases again. But so you have this kind of effect, but it's always good as a research lab and also as an industry to have a designated core group around the virtual reality. And that also needs to be part of your planning. So virtual reality by itself doesn't work if there's not a little bit of a responsibility, who is in charge of the equipment and who makes sure everything works. So that's pretty much our message on the budgeting side. You have to also like budget for the people that are running or actually in charge of the system.
Yeah. Yep. You're going to have to hire somebody to run it, or, be the person who runs it yourself. So, and we'll talk a little bit more about like DIY setups in a second too. But let's next topic here is installation. And thanks, Matthias, for jumping in there. And also, before I jump into installation, I noticed we're getting some questions, which is great. So keep submitting your questions. We'll definitely be doing a QA at the end where we can answer these in more detail. For an installation, it really kind of depends on the type of system, like the types of high-end projection systems, showrooms that Matthias was talking about. Obviously, the scope of installing this is a lot different. You've got to mount the projectors, you've got to run the cable, you've got to set up your workstation and everything. And oftentimes, you're training the personnel who are going to be running it as well. But for the smaller systems, installation is honestly pretty self-explanatory. We usually don't even include installation for our more entry-level systems because they are just right, for a Vive or for an Oculus, you pretty much put the headset on and it walks you step by step how to set it up. So there's some really cool sort of user experience considerations that we're taking into account in designing these headsets so that folks on their own can get this set up in a kind of home use setup. So definitely professional users, if you've got just a little bit of computer knowledge, aren't going to have too much trouble setting up a headset. Not the case for the large systems because it is going to be a specialty setup. Oftentimes, some kind of calibration, image alignment for the different projectors. So it can be a days-long process. For budgeting purposes, it's really dependent upon where you are. I mean, if we have to fly to the UAE with like a 3-person team for a multi-day setup, then obviously your, installation costs are going to be well above $10,000. But if you're, in North America, if it's easy to get to, it's a much lower cost in terms of installation, maybe $2,000 to $3,000 or $4,000, depending on how many days, how many people need to be there. What we try and do oftentimes is kind of wrap the installation and training in together as a little bit of a cost savings, because training is the other piece that you're really going to need to think about. A lot of times what we're doing for folks is we'll come on site, we'll give, a full day of training in both the hardware and the software, showing folks how to use our development engine, as well as, how to run the system, boot it up, what needs to be charged, what plugs in where, that kind of thing. So training is kind of a key component. There's different ways of doing training these days. Obviously, in the era of social distancing, we've been doing a lot more remote training. So if you needed specialty training in like art development or something like that, we definitely offer these services in terms of just getting on a shared screen and walking folks through a certain process. So that's one thing to keep in mind. Obviously, it's going to be a lot lower cost for remote training because there's no travel involved. So you could look at about $1,000 starting point for a personalized training session. But then if we're talking about a full 3 or 4 day seminar on site, depending on where you are, it could be up to about $8,000 or more. So it's really dependent on where you are, how many days, what you need, how specific the training content's going to be. If it's a more generic training, then it's a little bit easier to pull off, right? So those are all things to keep in mind. But it's definitely a good idea to think about training. Someday, and we'll probably do this again in the future, but for now, obviously with the pandemic, it's difficult. But we used to offer on-site seminars at our headquarters. So folks would actually come and we would give a full week-long training seminar in Santa Barbara, which was always a really nice thing for everybody because you can go to the beach and things like that. So hopefully we're all in a safer place soon, and we can get back to those days of our on-site seminars. But in the meantime, remote training is also very effective. So on the support side, this is something that I think is really applying to the commercially integrated systems, and we kind of refer to ourselves in this sort of terminology of commercially integrated, where you've got a professional company that's coming in, really putting all the pieces together and delivering. And part of that, of course, is not just the upfront work of making sure all the pieces are working together, delivering, installing, and training. It's also the ongoing support. So this can be things like troubleshooting, if an item breaks, replacing it. So it also can encompass a more extended warranty as well. And in almost all cases, when worldviz sells a system, we include a system or our software. We include a year of support as part of that upfront purchase cost. And that's really getting you access to a ticketing system where you can email our developers directly. It's also getting you access to the option to give us a phone call directly. So for troubleshooting and even for some development guidance, that's really what you're getting with support. So to budget for support, like I said, it's usually included in the first year, but future years are usually about 10 to 15% of the system cost, depending on what you really need. So that's it depends too if you're just going with software support or if you need software and hardware support. So it's a little bit case specific depending on what you need, but it's definitely something that for future years, for the ongoing support of the system, you're going to want to keep that in mind for what that's going to look like. And I would say that is really, one of the major advantages of getting a commercially integrated system is that, if you're doing a more DIY setup, it's up to you to do the research to figure out how something's going to go. But with a commercially supported option, you actually get to pick up the phone and call people, and they'll answer your questions. So that's a lot of what we do here at worldviz is every day we wake up and got all of our support tickets that need answering. So we try and get a response back within less than 24 hours. So that's just a little bit on the support side. I'm sure you guys understand a little bit of what commercially sophisticated support system looks like. So that kind of covers our whole different components of the VR budget. Now we're going to get into the application development considerations, and this is a pretty broad topic as well. Let us know if you think this would be worthwhile to do a full webinar on, but I'm just going to give kind of the whirlwind overview here, give you an idea of what the pieces are. And when you're developing a VR application, because most folks, you've got your VR system, you're going to want to have your own content, that's specific to your use case, whether it's some kind of a walkthrough or a product demonstration on the industrial side, or a very specific research application, like a pathfinding application or a human interaction application. Somebody's going to have to develop this content, right? And you really have kind of two options for how to develop that VR content. The first is the DIY, do it yourself, where you're going to, find folks internally or yourself internally to actually build that content. And then the second option, which we'll talk to a little bit, is just hiring a company, a studio, a development studio, somebody like us. We do this a lot to just build the application to your specific requirements. The thing to keep in mind, just to dive in here, there's going to be two primary components to every VR application. That's going to be your 3D graphics, which is, the actual props that are in the environment, and then the programming. And that's going to be any kind of interaction, hardware system that you have connected, all of these pieces. So all of the underlying logic for your application is a programming task, but then all of the environment is graphics. And depending on the complexity of the interaction, the programming can be a more intensive aspect, but a lot of times, it's fairly simple. And then on the graphics side, that's when things can definitely, depending on what people's expectation is for how the graphical quality of an environment should look, you can start to really see budgets get bigger there. I won't talk too much about the phases of development, but just to give you all an idea, you're going to really want to identify exactly what your project goals are. Storyboarding, all of this stuff saves a ton of time. Really important, especially if you're coming to a commercial company. The customer's always right, obviously, but we also have to work with you to very much crystallize the idea for what's possible, what's reasonable within a given budget, and really what the intended purpose is, so that we can make sure that the application that's being developed is going to meet that requirement. So the pre-production is a very key phase. From there, it goes into the internal workings, which is usually a prototyping phase where folks are, writing the logic with placeholder assets, things like that, meeting different milestones for graphic development and getting deliveries. And then, of course, quality assurance is always an important and sometimes overlooked aspect of VR development. You definitely are going to need to run your application over and over again. And we do a very strict QA process here where we identify all bug fixes and things like that. So after that, distribution and execution. With a program like Vizard, if you're just working with other labs or other branches of your own company, it's very easy to distribute our applications because with both the development enterprise version, you can publish your application once it's finished directly as an executable file. You have the unlimited ability to publish that and share it to all your different collaborators. If you're looking at more of a mass market application, then you're looking at a more significant process there, right? To get something on the Oculus Store, approved for the App Store, something like that. So if you're just doing more one-on-one stuff, our software makes it very easy to share finished applications. But again, just keep in mind, depending on where you want to go with your application, that final step could be a little bit more intensive. So I'm just going to speak a little bit to these different pieces here. The first one is graphics. Obviously, we have graphics and programming. The graphics, you, once again, have two kind of main options, right? The first is purchasing already built assets. Assets is what a broad term we use to describe any kind of 3D object, right? Because once you've got the 3D object, it's an asset that you have. You can use it over and over again. And there's a whole bunch of resources these days. It's really kind of incredible how much you can get online. The main places to go for 3D models, if you're looking to purchase some existing models, would be Sketchfab. It's kind of like almost like an Instagram for 3D models, or an Etsy kind of a thing, where you're able to purchase directly from the artists who are developing the content. And then TurboSquid is the way more, I would say, kind of established commercial place where folks are offering a whole bunch of really sophisticated models for like airplanes or different military things. So TurboSquid is really going to be a little bit higher cost usually than Sketchfab. Sketchfab, you're getting models for, in many cases free, but also for like $10 to like $35, $40 per model. TurboSquid, you're looking at more in like the $200, $300, $400 range. And then some of the more sophisticated models are definitely up in the kind of $1,000 plus range. So that's one option. The one thing to keep in mind about purchasing assets is they're coming from different resources, right? One artist has one way of doing things, another artist has another way. Oftentimes you bring these assets into a virtual environment, they're not all going to mesh with each other visually. So even though you might be purchasing assets to save yourself the hassle of building something from scratch, you're probably still going to have somebody with some 3D modeling knowledge to really make it a uniform environment where things might need to be cleaned up. That's just something to keep in mind. You can't necessarily always rely on just a purchase asset working right out of the box. The other traditional method of getting 3D graphics is developing the assets yourself, right? So there's definitely new ways of doing this. The one that we use the most is photogrammetry, which is an entire topic unto itself. But basically, you can get a camera and say, I want to get a model of this mug. I can take 90 pictures at this angle, 90 pictures at that angle, 90 pictures at that angle, put it into an algorithm, and it will spit out a model of this mug. And it's actually photorealistic because you're using a high-end camera to capture the surface. So it looks really good, and it oftentimes is fairly low cost in terms of development because you're not modeling from hand. But it is time intensive in terms of capturing the objects. So that's one method that we employ quite a bit. The other kind of traditional method would be, especially for industrial customers, engineers, you've got your CAD content, maybe, building information models, any kind of engineering schematic. These are long existing ecosystems that these things have been built in, and they're not really ready for VR out of the box. A lot of these systems have VR viewers, but if you want to put your engineering schematic in an interactive environment, then it's going to have to go through some kind of conversion process. And that's really where a 3D artist is going to be needed to do a cleanup of the model to make sure that it's VR ready. And then, of course, there's the traditional modeling by hand, right? So an artist is actually just inventing out of whole cloth, usually reference photos, things like that, what the actual object is. So once again, this is a huge topic, but hopefully giving you a little bit of an idea about some of the pieces that are going to go into your VR application development. The programming side, our academic customers have a little bit of an edge here because they oftentimes are able to leverage student programmers. So rather than having to hire a professional programmer, you can actually, reach into your computer science department. A lot of grad students are, pretty proficient with different programming languages. The main VR application development software that I outlined earlier, Unity, Unreal, and Vizard, they actually all use different programming languages. C# for Unity, C++ for Unreal, and then Vizard, our own software, uses Python. Python, we think, is it's very close to human language in terms of its scripting, and also is very commonly used in the academic market. So a lot of times folks are able to get started pretty quickly there, but obviously it depends on what resources you have available for your programming needs, right? So let's say, you don't really want to do, you don't want to hire, you don't want to go through the whole hassle of having to build a production studio in-house, right? What does hiring a studio look like? So what we're typically doing, I mean, we can work with customers to maybe develop an asset, or, help them with the programming. So we will do piecemeal production where we're kind of sharing the cost and sharing the effort across two parties. But the much more common thing that we see is what we might call a soup to nuts development project, where the client's coming to us with this, more or less a complete idea and asking us to come up with a budget and a timeline for when we can deliver that. The very minimum cost, I would say, for a pretty simple environment where you've got maybe we're leveraging existing assets or purchasing some assets, and there's kind of lower end interactivity, not anything super crazy in terms of logic. You're looking at about $15,000 minimum to develop, a pretty straightforward application. This might be like a simple research application where you're, doing some kind of pathfinding or something like that. The much more typical budgets that we see would be in like the $50,000 to $100,000 range for getting an application developed. That's going to get you a little bit more flexibility in terms of, how much art is getting done, how much programming is getting done to really kind of create a space. I've got this video here, and this is just to give you all an idea of a really kind of high-end, sophisticated application development, right? Something, this is a surgery simulation. There we go. We got the play button now. This surgery simulation, and we've shown this before in other webinars, but what you're seeing here, this was a very intensive project. I believe it was over $300,000 for the development of this environment. And that's because you've got all these different assets, right? You've got your entire hospital environment. And then, of course, the human body. Anything that's human related in terms of animations can be pretty cost intensive. So folks are like, oh, we want to have a virtual docent. Human animations, whether it's by mocap or by hand, almost always are going to be a big cost add-on. Discrete props or moving objects that don't have to convey like human emotion or anything like that. Those are a lot lower in terms of effort. But this is, you can see, highly interactive. We actually hired a subject matter expert, a doctor, to come in and advise us on how this appendectomy would be done. Our artists and programmers went and observed surgeries. So this was a month-long process, very involved. So, just to give you kind of a higher end idea of what these types of projects look like. But again, we can do pretty simple stuff for lower costs as well. So that kind of wraps up that section on the application development. Again, let us know if you've got questions. We'll be doing our QA shortly. And let us know, what you'd like to see in future webinars as well. If there's anything that we've kind of brushed on here, but you'd like to see in more detail. This is just bringing you in at the very, I want to get started tomorrow. I don't want to hire anybody. It's just going to be me. I want to do it myself. What do I need? Upfront investment. And that's, I think you can do it for $1,400 or less, right? And that's buying a gaming computer, usually pre-configured off of Amazon. You can get one that's VR ready for $1,000, sometimes less, sometimes a little bit more, depending on what you need. But that's kind of your minimum investment, is just having a good computer to run your VR experiences on, because you do need to have a decent graphics card for the rendering of the environment. And then just purchasing a low end, well, not low end, but a low cost virtual reality headset. So what we would probably recommend is the Oculus Rift S. That's going to get you really kind of off to the races. There's a ton of open source and free software options out there. So there really shouldn't, that kind of lower end, low cost DIY budget is pretty accessible now. I mean, if you compare it to what it was 5 or 6 years ago, it's actually pretty incredible how much more accessible it's become. To get more into like the commercial side of things, so this is really the systems that we're integrating. If you were to purchase just one of our entry-level systems that's including a license of our software, a computer, a headset, it also includes support, you're looking at between $8,000 and $15,000, depending on whether or not you're an academic or commercial entity again, and how high end of a computer you need, what type of headset you're looking for. So that's really, if you want to hire a company where you can call the support line and, everything's pre-configured and taken care of, and you're also getting the software, that's really kind of your entry-level point. We are now leveraging these really affordable eye tracking options as well. And that's been, I think, probably the most popular system that we've been working with lately, especially in our research community, because we actually have some specific software tools that we've developed to make it easier for researchers and for commercial entities to get the data out of their eye tracking hardware. So we did a whole webinar on that. That's actually really great. My colleague Sato did that whole thing. So our eye tracking systems, same thing as what you're getting with the headset VR, the computer, the Vizard software, and then an eye tracking headset. You're looking at between $10,000 and $20,000, just depending on, again, what your configuration is, what software you're getting. We have another system that we haven't even really talked about in this episode, but it's the worldviz VizBox. It's a highly portable system. It's fully contained in a Pelican case. So we actually developed that for our remote collaboration system. So if you need to do like a VR conferencing system, but the other person on the other end doesn't have a VR system, you can actually ship this box to them, and it's a fully built-out VR system in a box. That starts between $5,000 and $10,000 depending on your configuration. So different options here at the kind of more entry-level zone. But then if we're getting into the more like high-end spaces, projection, specialty, a lot of the lab build-outs that we see, they're going to be up in the higher-end budgets. I would say the minimum investment for a fully integrated like two-sided projection system, something to what you see here, is about $50,000, right? That, again, is not necessarily taking all of the different pieces into account, but, I would say we have like a higher end version that goes for about 75, and then you've also got to add installation and things like that. So it's just giving you a little bit of an idea of the types of budgets. So we're in a different realm here for showrooms, but that, as Matthias kind of pointed out earlier, is to be expected. So that's been our whole presentation now on the how to budget for your VR project. I hope this has been enlightening to all of you who might have had questions about what are the costs of these different pieces. I think Matthias is going to be kind of running our QA section at this point. I think I haven't had a chance. I've been zoned in on the presentation here, so I haven't had a chance to check out the questions yet. Oh, Matthias, I think you're muted actually.
One second here. Yeah, we actually got a whole bunch of good questions, guys. Thanks for asking
perfect.
Bunch of good questions. So while Dan was talking, I was trying to prepare a little bit visuals on the answer. So let's see if I can take over as a presenter here. And I show my screen, and then I have to, sorry guys, it's a little bit of a wiggling around here. I need to make this full screen here. So the first question that we got here was actually about how do phone-based VR systems compare in terms of capability, and how can they be used for research? It's a really good question, obviously, and because they're cheaper, typically they're cheaper. But what the phone-based VR systems need, unfortunately, is a higher level of optimization of the graphics. So when you buy like the original phone-based ones were just literally putting a Samsung phone or a phone into like a holder and using it in a VR mode. And that was in a way very restricted because that didn't give you hand tracking and also didn't update your position. So it had a higher likelihood of making you motion sick. These days, what we call phone-based systems is even systems like the Oculus Quest, which we call them phone-based because effectively they have the same processor as a cell phone in there. And but if it's a system that's so integrated and based on phone processing capabilities, then it's actually quite a good headset. What's still the case is that you have to optimize your graphics more. So if you're a researcher, you have to weigh kind of the deployment cost and the optimization cost against the lower system cost. And then the other way around, if you're a researcher, you might also want to measure like reaction and stuff like that. That might also be harder to do on a phone-based system because you don't have expandability. You can't add sensors so easily. So depending on what you want to do, we find phone-based systems good if it's a clearly defined thing that you want to deploy. That's where they come in really good, really handy, because then you can shrink the application down into something that's clearly defined and you can deploy it. But if your goal is a research lab and flexibility and the capability to change things around and add sensors and measure and iterate on it, then probably you're better off with a PC-based system, because the PC gives you those options, and then the graphic optimization doesn't become like an issue every time you want to do something. The kind of middle golden way here is existent. It's the Oculus Quest, because that is a device that has basically a self-contained phone side of it, but it also connects with the cable to a PC. So if you buy an Oculus Quest, you can use it as a PC-based one, and you can also see if you find use cases as a phone architecture-based HMD. So that was a really good question, whoever asked that. Let's go in the next one. The next one is, how good is treadmill-style VR equipment to simulate walking these days? And it happens to be that we had another webinar where we talked about hardware, and there was already some material available. And the material that we had available is showing Cyberite, like kind of treadmill, basically, where you're strapped in, and these treadmills you're strapped in and you're using your feet to basically navigate. That's obviously pretty cool, but in a way, it's no much different from you're basically using your feet as input, right? But in terms of you like maneuvering your real body around, you're still not really accelerating or decelerating, which means they're pretty cool devices to allow someone to maneuver in a space like without using the hand as input device with a joystick or something. Basically using your feet as input devices. In terms of like making you less sick, well, that's dependent a little bit on how it's integrated in the simulation, basically. So they're certainly functional, and Cyberite is a company that sells them for the business type application, and the original company that started this whole area was Virtuix Omni, and we were also like supporting those guys from the start, and they're a great company. And they are more focused on basically the gaming type applications. But they work for what they are. They're not taking away, they're not fully eliminating the issue of motion sickness. That really is more on the application side, how it's implemented. You can make implementations with Cyberite and Virtuix Omni that are really not causing a lot of motion sickness. But it depends on the software and the way you're using navigation, basically. There is actually really expensive, also treadmills. Like if you think of a treadmill, traditionally before virtual reality, you would have thought of an exercise type treadmill, like the one shown here. And we have researchers who also integrate like things like the Woodway treadmills, which is a very high-end company that makes treadmills for like workout type stuff. You can also integrate those into virtual reality applications. And for like also the purpose of being able to like control navigation with the speed you're walking or running, basically. Those guys are not made for walking sideways typically. But anyway, so yeah, it's a good question, and treadmills for specific purposes can actually work as a device that allows you to navigate a virtual reality world in a pretty efficient and fun manner. So yeah. So now I'm looking at a bunch of the other questions. One was, how should I pay attention to when selecting a graphics card to rendering PC? What should I pay attention to? As I said, like if you integrate for a head-mounted display, like a headset, you probably like have to look at the internet. What are good computers for effectively gaming? And currently, I would say it's a 2080 graphics card if you configure a PC. And but it always changes, right? Graphics cards, like new versions get released about every year or so. But basically, a high-end gaming PC for headsets, for head-mount displays, will do the job. If you have to configure a PC for a projection system, that is a more complicated question. That almost is something that we would have to individually look at. If you need very high rendering power, we would say let's use one graphics card for each projector, if that's possible. In terms of architecture, but then in theory, you can also use one graphics card for like 3 or 4 projectors. but then obviously you have a little bit less rendering power. So like, that's the trade-off. And we would have to look at that in an individual case and decide what's the best solution. So there's no one slam dunk answer for the projection PC configuration. The next question, does worldviz wizard system include virtual film production option? I'm not sure how that's meant. Maybe it's meant to be a 360 recording option, which makes it a pretty good question, because we have internally had requirements for that, and it is possible, but it's still in beta version, to effectively record a whole virtual experience as a 360 movie, which then makes it into a production system. So if you want to utilize such a feature for your own work, contact us directly. Send an email to sales@worldviz.com or support@worldviz.com, and we'll be looking at your individual requirements and can see if we can make that capability available. But it is an option that is in theory functional. It's also practically functional, but it's not refined. It's still in beta right now. So is there one single equation to estimate the price of a project? Also a really good question. That'd be the magic project estimate button. Like the answer is in a way no, because we would have to look at what's the goal of how to use virtual reality, and then depending on that, recommend hardware, and our hardware recommendations really depend majorly on the goal. Sometimes you would use completely different hardware for different goals. So there's not really one size fits all right now, at least not that we are aware of. So there's not one equation. We have made an effort to put a web page together that allows you to go through the different items discussed in this webinar. So yeah. And last but not least, during the pandemic, I think I might have lost the connection to the server here. Let's see here. 1 second, guys. Dan, are you still here?
Yeah, I'm here as well, Matthias. Sorry.
Okay, perfect.
Perfect.
Yeah.
Slides here.
So
let me.
yeah, the slides are in the slideshow. I hope it's now. I'm basically looking at the slide that details the question. During the pandemic, is it more viable and safe to still have users come to the lab to use VR equipment, or would sending it to them be an alternative? And I've just, like, when going through the questions, I've just copy pasted an image of our Viz box in here. So for commercial users, we have worked on this problem over the last, I think, 6 or 7 years. We have basically created an out-of-the-box virtual reality system that is an alternative, but the ones we have created are kind of more on they're not budget systems. So like there's the product Dan talked about it, the Viz box, which like it's a PC-based solution that's out of the box. And it costs about like $5,000 Viz box starting there. Like there's a higher end version that costs a little more. So it's an out of the box system. So yes, it could be sent. We are sending it to customers who never have used VR before, and in order to show them a virtual reality application. We have some commercial customers who use it to present to customers. So it's pretty self-contained and bulletproof, but obviously sending it out to like a myriad of students would be a pretty big price tag. And then also like when it comes back, it typically needs to be just checked and made sure everything works, like almost like in a library when you check something back in, you have to look and make sure everything works again and then it's checked out again. So with the right framework in place, it could be done. If the target is doing remote experiments, I'm sure it could be done. You need to like think it through, plan for it, and implement it. And it is functional. So you can have someone remotely strap in and interact and be part of the virtual reality session. But it's not really at the level of mass deployment right now, at least not that I know of, but it has been deployed successfully in individual use cases, right? So how many people can be expected to have access to the resources necessary for VR, whether there be sufficient space to use the hardware on their own in their own hardware. We have kind of had bad experiences, people using their own hardware, because individual PCs and individual hardware varies so much that becomes an exercise in supporting everybody's individual problems and virus scanners and firewalls and whatever not. So we recommend to send pre-configured hardware right now, simply because the variety is too high on individual people's hardware. It can be done in terms of how many people can connect to a system like that. Like the sky is the limit in theory. We have a version that allows presentations to like 5 users called Visible. You might have seen that. So that's shrink wrap that's out there that works. But if you need to connect with a whole bunch of different users, then you have to really ask again, what's the use case of that? Because if the use case is just a presentation, then maybe a combination of virtual reality for a couple people and screen sharing is an option. We have had some customers who are experimenting with that right now. There was a whole webinar on like remote work, remote research during the pandemic. So if you go on worldviz YouTube and search webinars, you can find it there. And that question was discussed in detail with a bunch of researchers. And
one thing too, Matthias, is our upcoming blog post is also going to be tackling the question of remote research as well. So if you're in our newsletter group, we'll be having a whole article on that in the next couple of weeks here.
Yeah, it's true. Yeah. So now the last couple questions I have to look at actually. Let's see. I might have not even seen them yet. What sort of hardware costs would be associated with in-house development of art assets? How high-end does a camera for photogrammetry have to be? What sort of hardware costs would be associated with art asset development? You need a capable PC, and you need to basically license or own some kind of a program that allows an artist to work on art assets. We find a lot of people are using 3ds Max from Autodesk, but there's a whole bunch of other software out there, including one that's, from what I know, free, Blender, that people have successfully used. So the hardware cost is really the PC, and the PC with a high-end graphics card, like basically a game quality PC and the developer and a nice big screen for them to develop on, right? There's not a huge hardware cost if you do it in-house, if you have a developer. But it's a lot of work sometimes, depending on which graphics you're developing. And the photogrammetry is a new method of developing art, as Dan pointed out. That really depends again on what you want to actually, in a way, scan with pictures. You have to use an array of high-end DSLR cameras and take like a lot of pictures. We have done for a fast food customer, we have done a project where we had to, I think, scan in, I don't know, like, Dan, you were part of that. How many items do we have to scan in? Like 200 or something, or like 100?
Oh, no, it was like 400, 500. It was quite a bit.
Items, right? And I think it was 90,000 pictures that were taken.
Yeah.
And then the rendering, like the computers did like a crunching for a couple weeks. But when you do that, you can make some pretty yummy pictures of food items. Like when I first saw that simulation, my mouth was watering. So definitely the outcome was mouth watering. So there's these different methods out there that can be employed. But obviously, if you need to take 90,000 pictures and crunch data for a couple of weeks, that also is not exactly super cheap, right? So there is work involved and effort. But outcome can be pretty real looking if you have the ability to scan your things in. And then the next question here: what sort of changes must be made to CAD model to have it ready for VR? That's again a really good question. You guys are asking really good questions. So when you have a CAD model and you want to see it in VR in real time, you basically, like, usually CAD models are designed to represent information as well as possible, with all the corners and all the lines and a lot of info in them. And when you look at the CAD model, oftentimes you have like hundreds of millions of dots basically. And now you have to take all these dots out of the CAD model and bring it into something that's real-time ready. And for real-time, you need to translate it into triangles. Out of all these dots, you have to make all these triangles, right? And somehow you need to put textures on the areas of the triangles. So that's really what needs to happen. So now there's programs that do that to a certain extent automatically, but depending on what your goal is, you have to interfere with it, and you have to manually change things. Like, because when you have like so many dots, you have to reduce the amount of data down to lesser, right? And if you want to run it on a phone, you have to go even lower in terms of triangles that you have, right? So when you do that automatically, then sometimes the outcome is not what you want to have. Like, it might not look the way you want it to look. And that's where the 3D artist has to come in and then basically decide what way of reducing it makes sense. Our customers on the professional side, the CAD customers, have good experiences with a company called Anarch, that's out of Colorado. Anarch really has like kind of worked on that problem for many years, and they have tools that they kind of automate that workflow. When you have defined what you want to do, then with Anarch you can kind of almost create a recipe how to make your CAD model into a VR ready file. So we have some customers who, after optimizing their stuff with Anarch, have brought the export time from the CAD model down into real-time virtual reality down from initially a couple of days to a few hours, basically, which then starts to be in that area where it's useful. You make a change to the CAD model, you export in 2 hours, and then you can review it in virtual reality. So again, it's a setup cost, but it's possible. Then, like last not least here, I'm not sure if that is the last question, but I'm reading. Oh yeah, it looks like it. With a simple environment like a garden or a house and an ability to walk and open and close doors, how much would you estimate the price of a project? Well, it depends on the visual quality that you need for the garden or house, I would say. But if you can just use a pre-existing garden or house and you need to just open and close a door, depends on your own capability, but like just buying the software like Wizard and getting support might actually be all you need, because we might be able to point you at a model of a house and a door, and guide you through being able to do it yourself. Or if it needs us, I would say on the if it's just opening and closing the door, then probably that's really a marginal cost. It's a couple of $100, probably less than $1,000 on the scripting side. The question is if the graphic assets already exist, like garden or house. So I think that was it on the question side, guys. I think we're wrapping up here. Dan, you wanna join on the video side one more time?
I'll say goodbye to the folks and thank them for their time today. We have a survey that goes out after these, and we really appreciate the feedback that you give us there, because that helps us make decisions about what the next topic's going to be, and also gives us an idea of how to follow up. And I think, Matthias, do you want to go to the last slide here where we've got our contact information, so we can
we can just switch to that last slide here. Just to say that the webinars are all recorded. This one also is going to be recorded, and on the worldviz YouTube channel, like it's really worth, like some of these webinars were, I think, pretty good in terms of giving info on how to design a system and how, like all these different questions that come up when you want to use VR. Sorry, Dan. Go ahead.
Oh no, please. Yeah, that's exactly. Check out our YouTube page. You'll see our other webinars there. And then if there was any question that you had, we'll try and follow up with folks who had questions directly. But if you have any questions, feel free to email sales@worldviz.com, contact@worldviz.com. We'll definitely be able to get back to you real quick. And also, we have a new feature on our website too, where you can request a quote directly. So if you check out worldviz.com and just request a quote on one of our product pages, we'll get back to you with a specific budget for a specific project. So looking forward to anybody's questions, and thanks again so much for joining us.
Yeah, thanks everybody. Have a good day or evening, depending on where you are.
Yeah. Take care.